quick explanation of imaginary numbers. And these are very poorly named because when we say they're imaginary, it makes it sound like they're not, real, or they're not an actual thing. But they are an actual thing. They are actually useful. They're used in engineering and things like that. You don't buy groceries with these. They're not like numbers we use to count sheep, but that doesn't make them any less useful. And so the word imaginary is just because when they first came up with them, they thought no one will ever use these. But it turns out that we actually do. And here's just the basic idea. You are probably already aware that if I ask you for the square root of, say, 25, that the answer is 5. And you know that that's true because you know that 5 times 5 equals 25. So we know that if we're asked to square root something, we're looking for a number that if I multiply it by itself, I land back on the number I had. So at some point in your life, someone probably asked you about the square root of something like maybe negative 25. And this means we're looking for a number that multiplies by itself 2 times to give us negative 25. And you find out pretty quickly that this doesn't really seem possible. Like, for example, you might think, well, I'll do negative 5. Maybe it's negative 5. That would mean that negative 5 times negative 5 is negative 25. But we all know that that's positive 25, so that's out. And of course, it's not 5 times 5. We already know that's 25. And then someone's like, well, what if I use negative 5 and positive 5? Well, awesome, except that we're not multiplying a number by itself, so that's also out. So I'm going to lie to you a little bit and say basically this concept of there's this idea of a number called an imaginary unit, and the imaginary unit is a number that when you square it, hold on, I have to sound this out, imaginary. Okay, the imaginary unit is a quote-unquote number that when you multiply it by itself, you get negative 1. And the first person who thought of this said there's no number that's like that, so it's imaginary, so we'll call it I. And it has the property that I squared equals negative 1. So similar to the way we use this symbol to talk about pi, and you may not even know this, but we use this symbol to talk about another transcendental number that's pretty crazy, blah, blah, blah. I is another kind of number. And I is a number that when squared equals negative 1. So we were using a symbol to represent a number where the numbers we have don't work. So if this little factoid is going to be true, it's also going to be true that I equals the square root of negative 1. So these are two little facts about imaginary numbers. I want to point another thing out. Sometimes kids make the mistake of thinking that I equals negative 1. This is totally and absolutely not true. We have a way to represent negative 1 with numbers. It's like this, negative 1. So this type of thing is not true. I squared is what equals negative 1, and I equals the square root of negative 1. So what we'll see is now if you're asked to square root a negative number, we can break it up like this. And then we know this part of it is a 5, and this part of it is just an I. So at the end of this whole kit and caboodle, what I need you to understand basically is if ever you're asked to square root a negative number, square root the number the way you always square root the number, but then you tack an I on the end of it. And that just tells the person, hey, what I square rooted was actually negative. So you'll see that as we go through the next few examples. But you definitely want to keep these two facts, I squared equals negative 1, I equals the square root of negative 1. Keep those two facts in mind because they're going to come up again and again and again.